state enterprise, academic, and more. This association regularly holds monthly meetings are our members. Which we have the pleasure of having Mr. Edmund with us today. So we also work with the so-called GIAN. GIAN stands for the Global EV EVAT is also working closely vehicles. Another event which EVAT holds on the annual basis is called IEV Tech. This is the collaboration between EVAT together with informal markets. We host the International Electric Vehicle Conference, and this year will be held from October 14 to the 16th. This year will be a total virtual platform. We have experts in various fields related to the electric vehicle from several countries who already accept our invitations to be part of the conference. And another point that I'd like to address, last but not least, is of course the fact that EVAT offers several communication platforms to bring knowledge sharing to the public via the EVAT online website, Facebook, LinkedIn, and others. This is overall snapshot of the Electric Vehicle Association in Thailand. And for anyone who might be interested to join us, please feel free to visit our website for more information. Thank you very much.
All right. Thank you, Mr. Krista. And now we will give the floor to Mr. Edmund to share with us on the outlook and trends in EV.
Okay. Thank you. Good afternoon. The slides there. On behalf of Asian Federation of Electric Vehicle Associations, we would like to thank you for giving us the opportunity to present before you on this event, our advocacy in promoting the industry on a regional level. Allow me to introduce what our association is all about. We were a non-profit organization from Asian countries whose mission is to promote the EV adoption and be a catalyst on the development and harmonization of the standards in the region. United as one through sharing, promotions, and facilitations of the best practices, research and development, continuous improvements, and industry networking. We started 44 years ago through organizing the first Asean Electric and Hybrid Vehicle Summit, which was held here in Manila, Philippines, with country representatives from Malaysia, Singapore, Thailand, and Philippines. First, some vehicle facts and trends in ASEAN region. As being seen on the screen, the average car ownership ratio per country and some insights on demand usage of e-commerce before, during, and after COVID-19 scenario. Car ownership ratio in the ASEAN market has a wide disparity. While personal cars are the most affected during the pandemic situation, commercial vehicles and motorcycles are expected to rebound faster due to the increasing e-commerce transactions, and motorcycles are expected to grow faster due to the need for personal mobility. At present, there are some statistics on the person per country basis with regards to EV stocks and its charging infrastructures, as stated on the screen. In terms of EV adoption trends, Thailand is getting its momentum on the numbers of BEVs on the road. Singapore followed with Teslas and Hyundai EV plants that are established. They also have some e-buses running on their areas. And as for the Philippines, e-trikes dominated the market as well as some light electric vehicles and e-jeeps. In terms of EV adoption targets, Thailand posted a bold move of about 50% vehicle production by 2030, of more than 1 million units by 2030. As for the version of the Singapore, they declared complete phase out of internal combustion engines by 2040, estimated of more than 100% of EV sales by 2031. While in the Philippines, a projection of more than 6 million units A study and survey from Deloitte and Frost and Sullivan are the following factors that will make difference with the car EV e-car adoption as to the safety standards, ability to charge at work, charging point at home, fast charge option, government incentives for consumers, and cost to charge. In summary, policy directions are essential. Most countries are keen on manufacturing incentives, while its consumer side incentives are limited to tax exemptions and reductions. Only in Singapore that provides e-car purchases rebates for consumers, and mostly are focused on supporting public transport EV adoption. Key takeaways: this pandemic has halted vehicle sales growth and shifted more of the demand to commercial vehicles and motorcycles. Its industry development and survival mostly drives EV adoption in the ASEAN region. E-motorcycles and other ELVs or electric in demand for e-buses, EUVs, and e-trikes in the region. The commercial vehicle segment could be a major EV market, but regulations will be needed to accelerate adoption. Thank you. That ends my presentation.
sustainable mobility. And of course, the third P is about possibilities. I think these three P towards sustainability, many corporate, many governments try to use this concept. So if we could balance all these three P, that would be, in that balance would be, we could find the sustainability. And of course, when you're talking about this three P, people are talking about, if you're talking about planet, we need to think about environments. If we're talking about the prosperity, we should talking about the how to bring the better economics. We're talking about people, how could we bring a better society to us. And then in the term of, if we talk about in terms of transport, if you want to go toward the sustainable transport or sustainable mobilities, I think there are three words that you should know. That is that the three words is called avoid, ship, and improved. So the first one, if you, I think that we try to avoid to traveling, so we produce less CO2. That we need a good system, right? Like what we are here today is, people about, I think I heard that about more than 300 people registered here today. So in the past, you have to come in, together at one place. People have to traveling. If these events have been in Singapore, I have to fly to Singapore, etc. So if we could, this kind of system can be avoid this kind of traveling. And of course, if you have to traveling, you might have to, try to not use your personal car. What we call, we need to shift it to the public transport, so that can make your travel is more efficient. And last one, you might not be able to, avoid or reduce, or you might not be able to use a public transport in some area. So you might have to use your personal car. So the best way is to use the most efficient vehicles. So that means we need to improve our vehicles, right? So I think that is what we are focusing here today. And in that, this kind of to improve our transport system and vehicle system. So they have some of new technologies that people call CASE. So CASE is stand for the first C stand for connected vehicles. The vehicle in the future will be able to connect it to each other. Even the vehicle could connect it to the infrastructure, right? I think maybe you're already familiar with this one. In some country, when you're going to a tollways, you might not have to, your car can communicate with the gate that they can pay the toll automatically. That's kind of connected vehicle is one of the good simple one of the example that we're existing today. But in the future, I think it will going to be more advanced than that. And then we're going to the A, which is autonomous vehicle, right? I think that quite a hot topic at the moment. We're talking about the 5 levels of autonomous vehicle. The level 5 is fully autonomous vehicle that you don't need a driver on the seat, right? And S, I think, is a new business of this mobility. It's called share mobilities. We're talking about our society. We become not exclusive but inclusive. That we probably could share some of the using of this mobility together. And the last one, I think, is what we are focused today is about the electric vehicles. So in my opinion, these 4 things, case will become, kind of a new smart car in the next 5 to 10 years from now on. And I think here today we are focusing a lot on electric vehicles. So I like to point out a few slides about this electric vehicle. When we're talking about electric vehicles, I think people are familiar with internal combustion engines, the hybrid one. And then when we're talking about EV, people would say, okay, maybe my EV is mean a battery EVs that's no engines. Some people are talking about it could be a plug-in hybrid EVs, right? So the name could be like plug-in EV that you can plug in the charging vehicle from the outside. But now there's a new trend that people are talking more about what they call zero emission vehicles. I mean, there's no engines that can emit the pollution, right? So vehicle like battery electric vehicle and fuel cell, it will become the zero emission vehicles. Fuel cells seem to be, a new technology that have been developed during the last 20, 30 years, but it's look like the battery electric vehicle seem to be more commercial and more affordable to the people. So I think this is probably my last slide to show that I think the battery electric vehicle would be one of the new trends for the next generation mobilities. As you can see, this is the components inside the battery electric vehicle. So the main one and the important part is, as you know, the high voltage battery, and you need the electric charging from outside the vehicles. And as you can see that if you look on the right hand side, that compare the performance of internal combustion engine and electric vehicles. Obviously you can have the torque performance even better than internal combustion engine when you have a good design on that. So, but anyway, the key issue of this technology still is the battery. So I think that's a very important issue here today. Right. So I think that's it for me at the moment. So thank you very much.
So thank you to the presenters before, and I take over for the last part of the presentations before we enter the Q&A with my presentation about the future of die casting and the impact of electric mobility on our industry. Now, before we have a look into what is the impact and what is the change on the parts that we produce in the die casting industry, I would quickly like to point the attention on this slide. We recently did a survey among our customers in the main automotive markets. Obviously, that's where we are playing as Bühler mainly. We asked them how much of your turnover today is made with automotive and how much of that is related to powertrain or to structural castings or to non-automotive or other. And it turned out that about 97% of the turnover of our customers, of Bühler customers, is in the automotive industry. And overall, 83% of the turnover is in powertrain, related to internal combustion powertrain. Now, let's do a quick survey among all the participants here, especially those active in the die casting industry, to see what result we get here if we talk about Southeast Asia. And for that, I would like to open a poll. I start now the polling, and you can see, I guess on the right side, you see polls, and you can put in your answers. How much of your turnover, if you're active in die casting industry, is related to the internal combustion engine powertrain, be it two-wheelers or automotive? Okay, let's just quickly see how the answers come in. So I see answers are coming in quickly. Okay, at the moment it's still quite diverse. We have the majority of more than 75%, but more and more also coming in other areas. So this shows US. So we let that ball run while I switch to the next slide and focus on what are the parts that are mainly produced in the powertrain today. And here we are talking about cars. It's not two-wheelers, but basically it's the same when we talk about the internal combustion engine powertrains. And as you see here on this slide on the left side, the picture of disassembled engine block. Now I need to quickly try to get to the drawing page. No, not possible. Okay. Here, let's start with the main engine block in the middle. This is typically a die casting part. We expect roughly 50 to 60 million such engine blocks are produced per year in the die casting process. Some of them obviously are still in gray cast iron, some of them are in gravity casting or sand casting. Then we have on the bottom usually the oil pan, which is a die cast part. Sometimes we have also a bed plate in between. We have the camshaft cover, or in this case the camshaft carrier on top. That is also a die cast part. We have the alternator housing here, which is usually two die cast parts. We have the air conditioning compressor, contains usually three die cast parts. We have other things like water pump housing, oil pump housing, turbocharger housing, throttle body housing. So many different kind of housings and parts you find in the engine alone. And if we look towards the gearbox, especially the most common automatic transmission gearboxes, obviously the gearbox housing is also a very popular die casting part. The clutch housing, some intermediate plates that we need, the valve bodies underneath, and drums in the middle of the gearboxes. So you see that traditionally a lot of die casting parts we find in the powertrain area and not too much out in a car outside of the powertrain. Now let's have a look how that would potentially change with the switch to electric vehicles. And we are actually convinced, we saw now before in the presentation that there are different systems like plug-in hybrids, like mild hybrids and so on. We are convinced at Bühler that the future of the car industry will be pure battery electric vehicles, and we see a huge growth all over the world for such vehicles, and they will look completely different when it comes to the powertrain. That's basically the whole powertrain combining the motor and the gearbox of an Audi e-tron, which is one of the first electric cars of Audi. And as you can see here in the middle, we still have a housing which is comparable to an engine block, but it's for an electric motor, the housing, but it already contains the half of the gearbox on the left side. It goes then more to the left side with the other gearbox here, with the other part of it. And as you can see here, that's basically only one gear. In the vast majority of electric vehicles, there is only one gear, so no need to switch. So the gearbox is much smaller, much less complicated. The motor housing, of course, is not always in die casting, sometimes or not in high pressure die casting, sometimes other casting methods or even extrusion is used for that, and we are fighting for the whole industry that more and more parts come into high pressure die casting so that the motor housing stays a big portion of the die casting business. Some motors also have a rotor that is made in high pressure die casting. It depends on the motor design, but in this case we have also a rotor where you have all the steel plates which are put into the mold and then cast overcasted with aluminum. Often the end of the motor, the bearing plate, is also high pressure die casting part, and usually then some pump housings. On top of that, you need an inverter for making AC current out of the DC battery, and this is in very many cases also made out of high pressure die casting. So this is basically the powertrain of an electric vehicle. Sometimes we have an all-wheel drive, then typically EVs will have those powertrain twice. So they have it on the rear axle and on the front axle. And not like in the internal combustion engine where you then have a transmission towards the rear or front end and have then an intermediate gearbox. So here you usually have then kind of two powertrain, which definitely helps for the volume in die casting if we have everything twice. But overall we can say in the powertrain of electric vehicles we have fewer parts and we have the tendency to smaller parts, with one exception, that's basically the motor housing, which is usually quite big. Now these parts, as you can imagine, they all are quite close to electronic components. For example, the inverter on top contains a lot of electronic components, sometimes needs to be cooled. Also the electric motor obviously needs to be cooled and is very close to electric components and PCBs and printed circuit boards. So there we have the necessity that this is completely pressure tight, and we need to avoid that we have a leakage of cooling water into electronic components. So that's one of the demand of the new parts in the electric powertrain. Now outside of the powertrain we see also other parts that can be battery boxes. Battery boxes so far were mainly made in high pressure die casting for plug-in hybrids like the one here on the left side. And this is just because the size of the batteries in electric cars is usually extremely big. It's typically from the front axle to the rear axle and everything in between, like we see here on the right side, the example again from the Audi e-tron. This is quite a big part, and so far it was not possible to make the complete housing in high pressure die casting with machine sizes of 4,000 ton locking force. Now, as you probably heard, the machine manufacturers, also Bühler, turned towards bigger machines, and we can now offer machines up to 9,000 ton locking force and a tie bar spacing of 2.5 meter. Therefore, we can also now look more towards making complete battery housings for EVs in high pressure die casting. But just to give you a size comparison, the yellow part here on the right side is made in high pressure die casting. It's basically under the rear seats of this Audi e-tron, and this part alone is produced on roughly a 3,000 ton machine. So imagine how big the machine would need to be if we do the complete battery housing in high pressure die casting. Anyway, there are other parts like this battery management module or battery junction box, which is also typically made in high pressure die casting. So you see, although there is definitely fewer parts, there is smaller parts, we also have some new parts that come with e-mobility. And I think this is a promising future, but we all need to be prepared to switch to these new parts and to know how to cast them. Another trend, this is outside of the powertrain and basically not related to electric vehicles, but it comes often with new startups, is the structural parts in cars. In the body in white of a car, we usually just had sheet metal, and in the 90s it already started to have more and more castings in the body in white in the whole assembly. It started often with the shock tower in the front, so this part here of the car. But now we saw more and more the trend towards the longitudinal members on the rear end, and this most prominent example here in the picture from Tesla, where they cast the complete rear underbody here, all of this part in one single shot on a 6,000 ton machine. They're also gonna produce the complete front underbody in one piece casting, and this is definitely a huge trend that we see for the automotive industry to go away from sheet metal assembly and sheet metal stamping and welding to castings and put it all in one shot to make 1/3 or even the half of a car underbody in high pressure die casting. But let's focus a little bit more on the powertrain parts and on the switch there. So what equipment do we need to cast these parts? Basically, the new parts for e-mobility, they are still die casting parts. Therefore, we will experience mainly the same errors that we know from, or challenges that we know from high pressure die casting parts that we used in internal combustion engines. As I said, they need to be pressure tight. We have to have a clear separation of the PCBs and the coolant. We have also more demand to this pressure tightness because we cannot accept any leakage. Let's say in an internal combustion engine, if you have some oil leakage, that's definitely not nice, but it will not kill the engine, but it can kill the motor of an electric car once it is filled with water. And therefore,